So quantum computing is going to be a revolution in how computing happens. The computer power that is going to be available from quantum computers is orders and orders of magnitude bigger than computers today.
Is this though coding? Is this companies? I mean, when we talk about, is it what exactly is it?
So if you want to do processing, weather forecasting, meteorology forecasting, the great thing with quantum computing, you can handle far more complex computations of huge matrices of information really quickly.
Okay.
That's a good thing. The bad thing is quantum computing is capable of breaking every crypto code in the world today.
Good grief.
That the world's economy or banks, enterprise security is all based on cryptographic keys.
Right.
Quantum computing will be able to break those keys somewhere probably starting 3 years out.
Good Lord.
And the defense for quantum computing in the past has been, oh, it's 10 years away, or, oh, you have to be a state level actor to get access to quantum computing. We as general business consumers don't need to worry about that today. However, we have companies such as D-Wave making their quantum computing capability available today.
Where are they based?
D-Wave is a US-Canadian company.
Okay.
But IBM have got a significant investment. But the important thing with D-Wave, they're one of the first companies to make quantum computing available on a timeshare basis in the cloud.
Interesting.
So you no longer have to be a state actor to gain access to the processing. The processing isn't quite powerful enough to break common or garden crypto.
Right.
But there are experts out there who are saying that within 3 years, common or garden crypto will be breakable.
Wow. So what's the best way for somebody to understand the concept of cryptographic keys? Is there a finite number of these? Are they, are these produced by technologists? Are these pieces of software? Just explain it for the, maybe the newer viewer.
So quantum keys are all over the world today. Whenever you log into a browser and you see the little padlock that says this is a secure session,
right?
That padlock means there's a cryptographic key process going on behind that's protecting and securing the communication between the desktop machine you're working on and the remote server.
Okay.
When you install Microsoft or an Apple product and it goes through a process, you may occasionally see it saying generating a certificate.
Yes.
So that maybe you have a code number you have to type in when you've downloaded some software on a website, so you can gain licensing access. That's protected with keys.
Okay.
Whenever you do a transaction with a bank, typically that's a secure transaction over the airwaves.
Okay.
And when we have usernames and passwords, essentially what's happening is the password is being used to encrypt a block of data that is then tied to the operation, to the secure sign-in. So all of those processes require cryptographic keys. The big question is, both now but looking to the future, when privacy and distributed data is going to become all the more important, is who generates the keys?
Yes.
Are they persistent?
Yes.
Or one time? Who can revoke the keys?
Yes.
Who can use the keys? And who can regenerate the keys if you want to gain access to some encrypted data, for law enforcement purposes, somewhere down the road.
Interesting.